Hi, this is Kelly Scott Sims, and I'm demonstrating my Project 1 Morse code on an Arduino. For my design, I wanted the ability to configure multiple pins at once without having to alter a whole lot of code. So for instance, if I wanted to wire up multiple LEDs or a buzzer, all I have to do is configure which pins in this single global variable, and the code will handle the rest and activate everything simultaneously. For my mappings, I've chosen to use a vector Morse code encodings. Because these are known compile time constants, we can just go ahead and actually organize these in a vector or an array of each encoding here. So here I have the array of everything here, where zeros Morse code encoding looks like this. It's 3 units, 3 units, 3 units, 3 units, 3 units, all the way up to a terminating int here. And this is a sentinel value so that the code knows that it's reached the end of this array for the 0 and can continue on. The indexing of this array is how we can map a character from its ASCII character to a position in this array. So we can see here that for the array, the values 0 through 9 take up the first 9 indices, whereas the capital letters A through Z take up the remaining 26 indices. So we can map a character from its ASCII value to an indice in this array for quick lookup by doing some ASCII manipulation. So for example, we can first determine if a provided value is a 0 or any ASCII character of a number by comparing its ASCII value. So 0 through 9 is 48 through 57 in the ASCII chart. So if the provided character's value is within this set and within this range, we know that it is a value. It is a ASCII number. Conversely, we can do the same thing for uppercase. They are encoded 65 through 90, and we can do the same for lowercase, which is 97 through 122. So if we want to convert, say, 0 to its index position here, which is 0 in the array, all we have to do, knowing that it's starting off at 48 in its ASCII character set, is subtract each integer letter by 48. So if 0 is 48, 48 minus 48 is 0, and that gives us index position 0 here. Same with ASCII character number 1. Its ASCII value is 49, so 49 minus 48 is 1, and that would give us index position 1. To handle uppercase letters, capital letters, all we have to do is take their ASCII encoding and subtract 55. And the reason for this, again, is because capital letters start at 65. And if we subtract 55, that gives us 10. Well, we want 10 because obviously 0 through 9 take up the first 9 indices of the array. So we want A to start at 10. So by subtracting 55 from each of the capital letters ASCII integer, we can correctly map them to their indice in this array for a fast lookup. This way we don't need any overhead of any dynamically allocated arrays, and we have fast constant time lookup here to save memory and computational space. So to test this out, we can just open up our serial monitor here. And currently right now I have it wired for pins 3 and 6, where on pin 3 I have an LED, and on pin 6 I actually have a buzzer, a piezoelectric buzzer. And let's see if I can't get this in here. So yeah, so we can see pin 6 and pin 3 has wires coming out of them, and they're coming here to the LED for pin 6, and then pin 3 has the piezoelectric buzzer here. So it'll make a sound and a pulse with each noise. So if we type in the word hello and send it, we're getting the light and the buzzing of Morse code here. Where here I have 1 unit as 300 milliseconds, so obviously 3 units would be 900 milliseconds, and 7 units is the 2100 milliseconds, or 2.1 seconds. Okay, so if I didn't want the buzzer to go, all I need to do is delete which pin I don't want, and I believe that's the buzzer. I might have just turned off the buzzer or the LED. Let's stop monitoring here, and then we'll re-upload. Okay, so we're uploaded now. We'll clear this out and we'll start monitoring again. And then we'll try hello again. And yeah, we can see this time no LED is going. We're just getting the buzzer. Okay, and then if we want to switch that back around, we'll just put 6 back in here instead of 3. We'll stop monitoring and we'll re-upload the code here. And then we'll go back to our serial monitor again. We'll start monitoring and we'll try hello again. Although this time we'll do hello world. We'll make it a little bit longer. And this time we are just getting the LED and no buzzing. So if we wanted to add more LEDs or more buzzards, all we have to do is simply add them to their own pin on the Arduino board, wire them up, and configure the pulse pins constant here to account for our pins, and then everything else will handle itself internally by the code. And that's my Morse code project.